Hi, assalamualaikum, and a very good evening to those who's watching this video right now, wherever you are. Welcome to this lesson on matrices taken from Advanced Higher Mathematics Unit 3. Before we begin, make sure you're confident with basic number operations like adding, subtracting, multiplying, and dividing, as well as basic row operation. So, the basic definition: what is a matrix? A matrix is a rectangular array of numbers called entries or elements. Each entry is positioned in a specific row and column. Order of a matrix. The order of a matrix is written as m times n, where m is a number of rows and n is a number of columns. For an example, the entry in the ith row and jth column is written as aij. This is called the ijth entry of matrix A. In this course, you'll mostly work with 2 times 2 and 3 times 3 matrices. Second of all, the special types of matrices. Main diagonal. What is the main diagonal? The main diagonal or leading diagonal of a matrix includes all the entries where the row number equals the column number. A11, A20, A22, A33, and the numbers goes on until A and N. The second part of main diagonal is row. The second part of special types of matrices is row matrix and column matrix. A row matrix has only one row. It's a 1 times n matrix. And a column matrix has only one column. It's a m times 1 matrix. And then a square matrix has the same number of rows and columns. M equals n. Next part is identity matrix. An identity matrix is a square matrix denoted by IM, where all entries on the main diagonal are 1, all other entries are 0. This acts like the number 1 in the matrix multiplication. For the last part is zero matrix. A zero matrix denoted by 0 m times n has all entries equal to 0. For a square zero matrix, we often just write O m. So that's all from me. I will pass next to my next colleague here.
Today we're going to talk about something super simple but super important, which is matrix addition and subtraction. The definition for matrix addition is add the corresponding elements of two matrices with the same order, same rows, and same columns. For the matrix subtraction, subtract the corresponding element of two matrices with the same order, same rows, and same columns. For the condition, both matrices must have the same dimension, same numbers of rows and columns. If not, addition or subtraction is not possible. So this is an example for matrix addition. For the first step, we need to check, are they the same size? Yes, both are 2 times 2. For the step 2, add the numbers in the same position. What I mean by that, just look at the top left. For matrix A, we have 2, and top left for matrix B, we have 7. So basically, we're just going to add 2 plus 7, which is we're going to get 9. We're going to continue to look at the top right. For matrix A, we have 3, and top right for matrix B, we have 1. At 3 plus 1, which is 4. And look at the bottom left, we have 4 and 0. 4 plus 0 is 4. And also bottom right, we have 5 and 6, which is 5 plus 6 is 11. This is how the calculation going to look like, and that's it. This is an example for subtraction. We're just going to using the same matrix. Basically, it's the same idea, but now we're just going to subtract it, and boom, just like that, we'll get the answer. I mean, if you can do a normal subtraction, you can do matrix subtraction. It is easy, but there's common mistake that people always make, which is number 1, trying to add or subtract matrix of different size. Nope, that is not going to work. Number 2, mixing up the position. Always match row with row, column with column. I think that's it for matrix addition and subtraction.
So now I would like to talk about matrix multiplication. Matrix multiplication is the process of multiplying two matrices A and B. Let's say matrix A be of size M times N and matrix B be of size N times B. The resulting matrix AB will be in size of M multiplied by B. So there is important condition. There's number of columns in matrix A must match the number of rows in matrix B. Otherwise, the multiplication is not defined. So this is an example we are given since A is 3 multiplication by 3 and B is 3 multiplied by 2. So we can multiply them. The result will be a 3 multiply 2 matrix. Let's compute A times B step by step. So we need to rows multiply by columns. So here we have a row which contain number 1, negative 2 and 0. Needs to multiply it with 3, 1 and negative 3. And then we need to repeat the same 2 times more using the other rows and with the same column, and then we need to change the column section part so that we can get the final result, which is will be AB equals to 1, negative 4, 21, 4, negative 20 and 32. And there's a key point, which is matrix multiplication is not commutative. So switching the order will give a different result or may be undefined.
A Boolean matrix is an M-bion matrix where all entries are either 1 or 0. There are 3 key operations on Boolean matrices. Join O are operation given to Boolean matrices A and B of the same dimension. The join of A and B, written as a B, produces a new matrix. See each entry siege is 1 if either ij or bij is 1. Otherwise, it's 0. Meet and operation. The meet of A and B, written as a B, produces matrix D here. Dij is 1 only if both ij and bij are 1. Otherwise, it's 0.
Consider these two 4x3 Boolean matrices A and B. Asterisk, matrix A. Row 1, 1, 0. 1, row 2, 2, 0, 1. 0, row 3, 1, 1, 0. Row 4, 0, 1, 0. Matrix B. Row 1, 1, 1, 0. Row 2, 0, 0. 1, row 3, 0, 1, 0. Row 4, 1, 1, 0. Results. The join of B is computed as follows. For each entry, take the OR of corresponding elements in A and B. The result is a matrix where any.
Okay. Hi, my name is Magarishi and I will be sharing about transformation matrices. Okay. Now let's see what's transformation matrices. A transformation is a way of changing points in space. For example, we can move a point x, y to a new position x prime, y prime after applying a transformation. Next, the theorem. A transformation matrix tells us how to move points. We multiply the matrix by the coordinate vector to get a new position. For example, x prime equals a times x plus b times y, and y prime equals c times x plus d times y, as you can see it here. Okay, now let's see some examples of finding a transformation matrix. So given x prime equals to x plus y, and this means a equals to 2 and b equals 5 as the first row of the matrix, and given one more equation, which is y prime equals x minus 3y, and this means c equals to 1 and d equals to negative 3 as the second row of the matrix, as you can see it here. Okay, one more example of image of a point. And so we are given transformation matrix with elements 1, -2, 3 and 0. So now we want to find the image of the point P with coordinates 3, -1. So now we multiply the matrix by the coordinate vector to get x prime equals 1 times 3 plus -2 times -1, which equals 5. You can see it here. And y prime equals 3 times 3 plus 0 times -1, which gives us 9. As you can see it here. So therefore the image of P after transformation is P prime equals to coordinate 5, 9. You can see it here. Okay, so let's continue with invariant points. So introduction, some points are left unchanged under transformation. If x is a coordinate vector of a point and T the transformation matrix, then the following definition can be made. As you can see, an invariant point is a point whose coordinates stay the same after transformation. This will be the equation. Tx equals to x. So example given. Find the invariant points under transformation described by the matrix 1, 2, 2, 3. So let's see the steps. First, we want to find all points of coordinate xy such that this will be the equation to do. So first, set up the equation. First, subtract the right hand side from both sides to bring to one side. So this will be step, and where I matrix 1 0 0 1 is the identity matrix. This is the identity matrix. Then you subtract and you will get the matrix 0 2 2 2. To that we solve the system of equation. So from matrix multiplication, this gives two equations. First, 0x plus 2y will be equals to 0, then 2y equals to 0 and y will be equals to 0. The second equation, 2x plus 2y equals to 0, and this will give 2x plus 0, so that means x equals 0. The final answer will be x equals 0 and y equals 0. We will get the coordinate 0 0. So next, reflection matrices. There are three reflection matrices. So first, reflection in the x-axis. The theorem given is a reflection in the x-axis is described by the transformation matrix. As you can see, the given matrix 1 0 0 -1. This is the theorem of x-axis. So for y-axis, the theorem is a reflection in the y-axis described by the transformation matrix of this matrix -1 0 0 1. So the third reflection is line y equals to x. So the theorem is a reflection in the y equals to x is described by transformation matrix, which is 0 1 1 0. Okay, next. Last but not least, rotation matrices. A rotation matrix is the matrix that rotates point in the coordinate plane around the origin 0 0 without changing their shape or size. For 2D rotations, this general rotation matrix of a counterclockwise rotation by an angle theta is, as you can see here, given. So cos theta, negative sin theta, cos theta. This is the equation now. So example given for 90-degree rotation counterclockwise. So let's rotate the point of 10 coordinate 90 degrees counterclockwise. So first to rotate matrix for 90 degree, you can just use this formula. Just you replace the 90-degree inside, and so you'll get this matrix 0, -1, 1, 0. After get this answer, multiply with the point to rotate. As you can see here, and you will get 0, 1. So the rotate point 1, 0 becomes 0, 1. That's the answer, final answer. Okay. Now for summary for transformation matrices. To summarize, transformation matrices enable us to execute geometric transformation such as reflections and rotations effectively through matrix multiplication. These matrices give us a structured way to move or change points in space. So that's all from me. Thank you.